How long does it take to double the investment? Hey guys, so welcome to our new video about interest and investment. In our last videos, we have seen that if you make a recurrent investment of $1 with an R monthly interest with a capitalization that's done monthly, after X month, you will have MX 1 plus R to the X minus 1 divided by R amount of money. Now, there's the following interesting question. How long does it take to double the investment? This is the question that we want to answer in our video. We've seen again in the last video that this is the amount of money that you get after X months. Now, one other interesting thing that before we go into our proof, let's remind us about the W function or Lambert W function. If you have the equation x times e to the x equals y, the solution is not a logarithm, is not a trigonometrical usual function. It's called Lambert W function. So x is actually equal w, that's the name of the function, of y. What's interesting is that this is a multi-value function. That is, it doesn't have only one single value for every argument. So let's bear this in mind before we go into our actual proof. Now, in order to double the investment, we have 1 plus R to the power of X minus 1 divided by R equal the actual amount of money that was invested. And because we invested $1 per month, the total amount of investment is actually X. Because we have X months of investment, X being the actual unknown, the actual argument, the one that we want to solve for. But it's not enough because we want to double our investment, we need to put a 2 here. So we have to solve actually this equation. And this seems a little bit simple in the beginning, but let's see what it has to offer. First of all, this is not going to be solved with our regular logarithm, exponentials, and trigonometrical classic functions. We will need, obviously, the Lambert W function, because otherwise, why would I put it here? What we want to do is to reduce this equation here to something that looks very similar to this one. So first of all, let's try to work a little bit with this. Let's put the R in the other side, and we get 1 plus R to the power of X minus 1 equal to X R. We can put the 1 in the other side, and we have, let's write it over here, 1 plus R to the power of X equals 2X R plus 1. We can multiply with 1 plus R to the power of minus X, so that we can have 1 here and the exponential in this side and also the polynomial function here. So we have 1 equals 2x r plus 1 times 1 plus r to the power of minus x. We can factor here for the 2r so that we don't have any sort of coefficient to the x. We have 2r x plus 1 over 2r times 1 plus r to the power of minus x. And now it looks quite interesting because we have here an exponential. It's not e, the base. We'll solve that a bit later. And we have here the exponent that's x. And here we have the other polynomial function x here, but it has a plus 1 over 2r here. Now this one we can solve very easily. If we want to have exactly this value to the exponent, we can easily just multiply by 1 plus r to the power 1 over 2r with a minus in front of it. So we have 1 plus r to 1 over 2r with a minus equal 2r times x plus 1 over 2r 1 plus r minus x plus 1 over 2r, and this is parenthesis over here. And you can see now fairly easy this part over here. Let's market correspondingly is very similar to this one right here. Exception is that we don't have a minus, so we can easily multiply by -1, and then we have minus 1 plus r to minus 1 over 2r equals minus 2r x plus 1 over 2r. And now they're almost identical. What we still don't have is e, but we can tweak that as well. And we put e, but then we need to put it 1 over r here. And this actually is 1 over r. You can exchange it with e, and then you have a natural logarithm, n is a 1. Multiplied by x plus 1 over 2r, and that's with a minus over here. The logarithm is only for this expression. Let's move a bit on. And now, again, we don't have the same value to the left. So we can multiply here by a logarithm of 1 plus r. And we have minus natural logarithm 1 plus r multiplied by, and here we have minus 2r, might as well put 2 over r here, and we have 2 over r 1 plus r. And now easily we'll make a substitution because we have minus this here, which exactly is mirrored right here. So we have y equals minus natural logarithm 1 plus r times x plus 1 over 2 r. And then our problem becomes minus natural logarithm 1 plus r. And here we have something very similar to the Lambert W function. Now we have to solve for y. And y will be equal to w. And because y is equal to this one over here, finally, when we solve for x, we have, let's write it in red, x equal. So this right here, my dear friends, is the amount of time in which, if you invest $1 per month with the R rate interest, with a capitalization monthly, this is the amount of time in which you will double your amount of money. Thank you for watching.